In this section, we will be learning about constructing class intervals and also choosing the class interval width. Notice that in this example table that we have, the different class intervals do not overlap. Consider, for example, the interval 80 to 84, and the next highest one is 85 to 89. It is impossible for a score to be in both intervals simultaneously. This is important because it would become very confusing if a single score contributed to the frequency count in more than one interval. And it is also important that there is no gap between the two intervals. Otherwise, a score could fall between the cracks and not get counted at all. Bear in mind that even though there appears to be a gap when you look at the apparent limits, like when you look at the class interval 80 to 84, and then in the next interval we have 85 to 89. The gap disappears when you look at the real limits, which could be with 80 to 84, that is 79.5 to 84.5. Remember, in our previous discussion and example, if we are dealing with the upper apparent limit, like for example, in the case of the class interval 80 to 84, 84 is the upper apparent limit, and we only have to add 0.5. If in case we are dealing with a continuous variable, to also have 84.5 as the upper real limit. And on the other hand, if we want to also know the lower real limit in the case of the class interval 80 to 84, 80 is the lower apparent limit, and we only have to subtract 0.5, and we could have 79.5 as our lower real limit. That's only the case if we are also dealing with a continuous variable. So even then, when you would also be utilizing the real limits of the class intervals, there is still no overlap. Perhaps you are wondering what happens if a score turns out to be exactly 84.5. First, when dealing with a continuous scale, the probability of any particular exact value arising is considered to be too small to worry about. In reality, however, measurements are not so precise and such values do arise. In that case, a simple rule can be adopted, such as any value ending exactly at 0.5, like 84.5, we should be placing the higher interval if the number before the 0.5 is even. So in this particular example, if our upper real limit is 84.5, then we should be putting 84.5 as our higher interval, because again, we could also be following the simple rule that if the number before the 0.5 is even, then we should be putting such value as the higher interval. Now, let's move on to choosing the interval width. So how do we know that we have to have an interval width of about 10 or 5, 2, or 3? In the previous examples, we have scores of 80 to 84 and also 85 to 89. So in this case, the interval width, which is equivalent to 5. So 80 to 84, so we should count starting at the lower apparent limit, which is 80. So 80, 81, 82, and 83, and 84. So there is about an interval width of 5. Before one can create a grouped frequency distribution, one must first decide how wide to make the class intervals. This is an important decision. If one makes the interval too large, there will be too few intervals to give you much detail about the distribution. For instance, in this particular example table we are seeing, this is an example of a group frequency distribution which has about how many interval or how much interval width. Now, if your response is 10, you are correct. Again, we need to count including the lower apparent limit, which is 90, and then we go to 99. So if you count starting 90, you would also notice that it has about an internal width of 10. In the example table that we have, such a grouping could be useful if these class intervals actually corresponded with some external criterion. Like for instance, the class intervals could correspond to the letter grades of A, B, C, and D. A meaning having the highest score or the perfect grade. However, in the absence of some external criterion for grouping, it is preferable to have at least 10 class intervals to get a detailed picture of the distribution. Again, let me repeat what I said. It is also recommended in the absence of external criterion, at least we have about 10 class intervals, not interval width. On the other hand, if you make the class intervals too narrow, you may have so many intervals that you are not much better off than with a simple frequency distribution. In general, more than 20 intervals is considered too many to get a good picture of the distribution. In this example table, to have a class intervals between 10 and 20, one would need to also be grouping the intervals with interval widths of about 3 or interval width equal to 2. So the distribution with interval width of 2 is too similar to the simple frequency distribution to be much of value, but the distribution, as you are seeing in the example table, the interval width is just equal to 3, and it is informative as you are seeing it. And of course, if you would somehow try to compare it with our previous example table, which also has an interval width of 10.